I would like to introduce James Carpenter. He's the ESA Moon Utilization Manager. And I don't want to take any more of your time. James, are you available?
I am. I'm here. Can you see me and hear me?
We can.
Marvelous.
Thank you.
Okay, so I'm going to attempt to share my screen. I can work out how to do that with this.
At the bottom, the green arrow.
Ah, yeah, sorry. Right, there we go. Okay, so can I just check? Are you seeing something?
We are.
Marvelous, good. Anyway, so thanks very much for having me this morning, this afternoon, this evening, wherever you are. Yeah, so my name is James Carpenter. I'm from the Directorate of Human and Robotic Exploration, the European Space Agency. I'd like in the next few minutes to give you a bit of an a view of what is happening currently within ESA, within our program, and some perspective on what perhaps is coming in the next years. So I know you heard from my boss earlier in the week, from Dave Parker. I know he gave you a great overview of the program and the plans. So what I hope he explained to you is that we are currently in, we have a program called the European Exploration Envelope Program, or E3P, which is becoming something new, which is called Terra Novae, or New Worlds. And at our last ministerial council meeting, when big budget decisions were made, at the end of 2019, we got approval to start a new program for lunar exploration. And in this program, we have a number of elements you can see here in the view chart. So the first of those is, if I remove this, okay, so the first of these is the Orion, or our contributions to Orion, so the European Service Module for Orion. We also have contributions to the Gateway, so that includes the international habitats and various other systems that are going on Gateway. And we're now beginning our first payload developments for the first utilization of Gateway for science. We're also contributing to missions with international partners going down to the lunar surface. So you see here Lunar 27. There are others, and I'll talk a bit about those in a few minutes. We've also started the development of some new activities. So the first of those is what we call the European Large Logistics Lander, which will be a lander capable of delivering around 1.5 tons of payload to the lunar surface for logistics and for science. We're also looking into a cislunar transfer vehicle to provide logistics support in cislunar space. And we're looking at developing a communications and navigation service around the moon, working with our partners in telecommunications and navigation within ESA, and with commercial partners too. So putting all this together, it provides us with a package to provide sort of European science and technology at the lunar surface, but also provide contributions to participate in Artemis and programs with international partners. So what we want to achieve in all this, and I don't have very long, but in summary, we want to understand what it means to live and work in the lunar environment. We would like to understand potential resources and establish how we might use them in a responsible way in the future. We'd like to establish the moon as a platform for sustained scientific research and utilization going into the future. We want to make sure we create roles for European industry and commercial opportunities for the European economy. We want to build international partnerships that enable exploration for the near term and the longer term, and learn lessons from what we do on the moon to prepare capabilities that we can take onwards for the exploration of Mars. So I'll go through a little bit about some of these things and what we're doing in this period of our program to respond to some of these things. So the first thing will be about preparing to live and work in that environment. So what we're doing now is we're starting to work to characterize the integrated environment. So that's radiation, plasma, dust, and those other things in the Gateway environment and at the lunar surface. So what you see below here are two payloads. The first of those on the bottom left is, I guess, a very early CAD model of something called ERSA, which is the European Radiation Sensor Array, which will characterize the radiation environment outside Gateway. And we're also looking to characterize the radiation environment inside Gateway to understand what that means for the risk factors for human exploration. We're also working on things to go to the lunar surface. On the bottom right there, you see something, the heart of an instrument called the exosphere mass spectrometer, which will characterize the exosphere at the lunar surface as part of a collaboration with NASA on the Commercial Lunar Payload Services Program, and I'll talk more about that in a moment too. So we're looking to characterize those environments. We want to determine the environmental impacts of human activity, how we change the environment. We want to measure the effects of the environment using ground-based research facilities at Gateway and at the lunar surface. And we want to learn how to mitigate the environmental risk factors for technology, biology, human health and performance. So we've started some serious work on that. The second part, maybe to talk about our ESA contributions to what I've written here, you can't see, is to an international program or international campaign of lunar polar prospecting to look for ice and other potential resources at the lunar poles. Now, this is pretty exciting. What you see internationally right now is there are missions from all over the world going to the lunar poles, in particular the South Pole, to map really the regional distribution and properties of water, ice, and other volatiles there, both for science and as a potential resource in the future. And we're contributing now to a number of missions with international partners. So you heard earlier in the week about Prospect. I think you've probably heard about the EMS as well. So Prospect, you see here, is a package to drill into the subsurface, extract samples, and then analyze those to look for water ice, its origin, its evolution, its properties, and other volatiles that are in there too, both for science and also for exploration, for resources and understanding them. So we're building the Prospect for the Lunar 27 mission as a partnership with Roscosmos. We're now preparing a second build of the complete Prospect system as a cooperation with NASA for a commercial delivery, which we're expecting circa 2024. We're working on EMS, which is this bit of the subset of Prospect, which is a small mass spectrometer. And we're developing that now both for a precursor mission as a partnership with Goddard on the PITMS instrument for CLIPS delivery intended on something at the end of this year with Astrobotic. And also an evolution of that instrument we're looking to fly now with JAXA as well on their LUPEX rover. And so with these, we're contributing to a number of different missions to understand and explore the polar regions for science and exploration. And on the right-hand side of this image, you see the flight hardware that's been delivered now to the US for integration with the Astrobotic lander for this first delivery of EMS to the surface of the moon with PITMS. And the drill bit you see there, by the way, that's the drilling and sampling mechanism on the end of the Prospect drill, which will go a meter beneath the surface. And also now, so that's, if you like, the first phase of exploration like this is to explore the distribution of volatiles around the regions in the polar regions of the moon. And then the next stage would be to integrate that into a geological model of where we think resources would be and to go and explore those in more detail. And for that, we have a pre-phase A mission study ongoing with the European industry to look into a polar explorer mission to go and explore a resource deposit. Second thing we're doing is we're preparing in situ resource utilization. So for that, we have a number of activities going on in ground-based research into ISRU processes. And we're also working on an in situ resource utilization demonstration mission concept for a decision in 2022, which is when our next ministerial council is to decide the future program. On the left-hand side of this image, you see the example. I think it's quite an old picture now. Most of you have seen this before of where we've taken a regolith simulant and we've performed a reduction process on it. And on the right side, it's shiny because it's mostly metallic. On the other side, we've taken all the oxygen out of those samples. As we credit Beth Lomax with doing the research that led to that image. And on the right-hand side is the outcome of one of our early studies into this ISRU demonstration payload to take one of these processes to demonstrate it on the surface of the moon to produce oxygen from lunar minerals. And then we want to prepare the surface of the moon as a platform for future research, for future exploration. So to do that, we want to provide early science on the surface with partner-led missions from the early 2020, from now. So on the bottom left, you see like the first example of this, which is a lunar laser reflector being developed by INFN in Italy, which we're contributing to a NASA-led commercial lunar payload services delivery in 2023. And we're developing that now to flight. We're also looking to prepare science deliveries from the mid-2020s with international partners, or that could be with a commercial delivery from ESA. We're looking to contribute to international lunar sample return, and so we're developing the capabilities in Europe for that as contributions to that, and also how we might contribute to that through Artemis as a whole and our contributions to Artemis. And we're looking to prepare research missions and infrastructure that we could develop in Europe as part of an international campaign of lunar exploration for the late 2020s onwards. And so for that, we have topical teams, scientific topical teams that are in place, and many of you are here now, and thank you for everything you're doing to support us. So topical teams are defining what are the science goals, what are the objectives you want to achieve with that. In parallel, we're running a number of phase 0 and pre-phase A studies internally at ESA and with industry on missions and on payloads that could deliver on this science. We're looking specifically at polar exploration, at geosciences on the moon, and astrophysics, in particular looking at from the lunar far side, looking at long wavelength radio, and life sciences, how we might use the lunar surface as a location to understand the effects of different environmental risk factors on different kinds of biology. And on the bottom there, you see some examples of just some early catalogs and some of our internal studies looking at some early examples of what these might be, and their delivery with the large logistics lander that we've started development of now. And then as we look forward, and as we look forward to the future program, so at the end of this programmatic period, which will end at the end of next year, we will go into the Ministerial Council of 2022, preparing it to request a new program. And while that program proposal is in preparation now, some of the things that are likely to be in, or we were considering going in there, would include developments to flight of payloads for partner missions, payloads for potential ESA-managed commercial payload deliveries, and payloads for the first EL3 mission, which would include science and technology from Europe, alongside potentially cargo for Artemis or other contributions to lunar deliveries. We will be looking at starting phase A and B1 and technology developments for candidate lunar missions and for candidate lunar payloads for later missions, and looking at starting phase 0 and pre-phase A studies for very new and novel mission ideas or research facilities for the service of the moon, and for novel lunar payloads. And while we have a lot of activities running now, we are currently preparing payload and mission selection processes. So we've created in the last years a lot of options, and now we have to work with our member states and our stakeholders to define on how we're going to narrow that down to decide the things that we are going to do. And so in the next months, I hope you're going to see from us some information, some communication on the processes that will be applied to take decisions on what we fly and what we develop, and how you can be involved in supporting and responding to those opportunities. And that's everything from me. Thanks very much.
Wonderful. Thank you. That was a great overview, and you got a lot in the time we had. Oh, great. We have a question. This is from Mahesh Anand. Great presentation, James. If all currently US ESA-backed lunar missions comes to fruition by 2025, then do you expect the next phase of ESA-backed lunar missions to be sample return from polar regions for developing a better understanding of lunar resources?
So we're investigating a number of different mission types. I would say that we had actually ruled out for the time being an ESA-only sample return mission. I think the emphasis from ESA would be to work on contributing to Artemis, so that we can participate in a deep way in the Artemis program and provide benefit for the European science community in terms of samples by cooperating with the US on that sample return from Artemis. Space resources and understanding space resources is going to be part of what we do in the coming phases, alongside pure science. I mean, we're going to have a mixed portfolio. Space resources is definitely going to be in there. And I think it's going to be a growing topic internationally in the coming years. And I hope that Europe will play a substantial role in what's to come. I hope that answers your question, Mahesh.
Okay, great. And I have one question. Did I hear correctly, and if I'm wrong, I apologize, that there is a partnership with ESA for PRISM? That's the next PRISM call that's coming out of the US, or am I mixing that up with something else? So, I mean, I'm perhaps referring to the PRISM call specifically. I think I would defer comment on that to NASA colleagues who are running that. Okay. But we are working. I know it's a NASA. I know it's a NASA program. Yeah. I thought there was a European element to it. So there are two payloads that we are working with NASA to potentially fly
as part of CLIPS deliveries. One of those would be a laser retroreflector.
Yeah.
And the other is the full prospect package as a contribution to this broader campaign of lunar polar exploration to understand the volatiles in the lunar polar region.
Okay. Okay, wonderful. Well, keep an eye on the chat if you could. There's nothing else right now. Oh, and Ryan Watkins, just to clarify, what I was confused with is it's Canada. So apologies, James, for putting you on the spot.